It is estimated that we use a staggering 320 billion kilowatt-hours of energy every day. While most of this enormous requirement is addressed by burning fossil fuels like coal, petroleum oil, and natural gas, there are some exciting alternatives which are promising a cleaner and greener future. These are the 10 most promising future energy resources. Tidal power. Tidal power is one of the major renewable energy sources, but is in its early stages. It harnesses the energy from the tidal source, and wave action from the gravitational pull from both the moon and the sun. Tidal power can be generated using 3 technologies. Barrages, or dams, are built across the bay or river estuary, which by controlling the flow rate through the turbines generates electricity. Tidal fences are a type of tidal power system that has vertical axis turbines, mounted in a fence, or row, placed on the seabed. Tidal turbines are arranged under water and roads like wind turbines. Researchers feel that tidal technology development is more reliable and the quality of the power produced by tidal sources is better than other renewable resources. So, tidal power will play an important role in future technology. Vortex bladeless. Any wind generator is potentially dangerous. The machine kinetic power is almost impossible to control. That is why, such power stations are typically mounted in remote places. This problem was addressed by the Spanish company Vortex Bladeless. Such wind generators turned to be more efficient than traditional blade ones, and required less time and money to install. Furthermore, the system does not actually entail large rotating elements. The working principle of platelets generators is way more difficult, but its efficiency could never be denied. Vortex flows blow at a vertical generator, thus moving the power generating axis. Obviously, designers do not disclose technical details. However, a single 492-foot high generator of this type can produce up to 1 megawatt of electricity. Thorium. The thorium is the 90th element on the periodic table. Another chemistry lesson from the school, the second heaviest element on Earth. Thorium is a basic element of nature, like iron and uranium. Like uranium, its properties allow it to be used to fuel nuclear chain reaction that can run a power plant and make electricity. Thorium is around 3 times more abundant than uranium in the Earth's crust. Since the beginning of the nuclear era, significant scientific attention has been given to thorium's potential as a nuclear fuel. A thorium reactor burns nearly all of its fuel. As a result, it will produce less waste. Thorium reactors are a different way to generate electricity that could benefit the world. More efficient than their fossil fuel counterparts, safer than a conventional nuclear plant, and generating no carbon emissions as a byproduct, LFTRs are a viable solution for the future of our world's energy needs. Hydrogen. A colorless, odorless gas, hydrogen, which we all know from the chemistry class, accounts for 74% of the total mass of the universe. It can be considered as the simplest element in existence, which is abundantly available on the Earth, but not in pure form. As the hydrogen gas is lighter than air, it rises into the atmosphere. So hydrogen as a gas is not found naturally on Earth and must be manufactured. Hydrogen has the highest energy content of any common fuel by weight, while also being the lowest energy content by volume. Currently, hydrogen is mainly used as a fuel in the NASA space program. Hydrogen will join electricity as an important energy carrier, since it can be made safely from renewable energy sources and is virtually non-polluting. It'll be fuel for zero-emissions vehicles. Biofuels. Unlike other renewable energy sources, biomass can be converted directly into liquid fuels, called biofuels, to help meet transportation fuel needs. As biofuels emit less carbon dioxide than conventional fuels, they can be blended with the existing fuels as an effective way of reducing CO2 emissions in the transport sector. New technologies and processes that produce fuels from waste, inedible crops which are known as advanced or second-generation biofuels. The 2 most common types of biofuels in use today are ethanol and biodiesel, both of which represent the first generation of biofuel technology. Second-generation biofuels are derived from lignocellulosic crops and can be manufactured from different types of biomass. Interest in the use of biofuels worldwide has grown strongly in recent years due to the high oil prices and concerns about climate change from greenhouse gas emissions. In the future, they can be particularly important to help decarbonize aviation, marine, and heavy-duty road transport sectors. PaveGen. People get more dependent on fossil fuels to produce electric power year by year. Resources don't add up, while the power consumption keeps increasing. The problem was of great interest to Lawrence Kemble Cook. As early as in 2009, when he was a student of Lowbrow University. In 10 years, he managed to create the Pave Gen Company. It manufactures sidewalk tiles that can convert pedestrians' energy into electrical power when they're walking of. The tiles are made from recycled abrasion-resistant automobile tires. When stepped, the tile surface suppresses by 0.2 inches, inducing the indole transducer to generate electrical power. The energy can be used for sidewalk lights or accumulated in lithium batteries. The company's technology of this power generation is still kept a secret. Solar windows. Scientists have invented a new technology that will turn any window or glass into a photovoltaic solar cell. So your windows will turn into a solar panel. Solar windows passively produce solar power, and they could be a game-changing clean energy technology. Solar windows are exactly what they sound like. Transparent windows that are capable of absorbing sunlight and turning it into useful electricity. These windows are capable of harvesting the part of the solar spectrum the eyes can't see and convert it into electricity, while letting regular visible light to pass through. Skyscrapers and other large buildings with glass facades use a coating on windows to reduce the glare and heat of the sun. So they can use sheets of transparent solar cells, which will help to produce electricity to power the building too. Solar windows offer vast potential as an energy source. Renewable energy truly is having its moment in the sun, and this homely technology might play a significant role in our fight against climate change in the not-so-distant future. The current situation of this technology is not exactly awesome, but this is a step forward in figuring out how to turn windows into clean energy. Flying wind farms. As oil companies drill ever deeper to meet the world's thirst for fuel, a new wave of clean energy entrepreneurs are also searching far and wide for sources, but in the opposite direction. As you go higher, ground friction diminishes, giving way to increasingly stronger winds up to 100 miles per hour. Wind farms are constructed to harness this mechanical energy from the wind and convert it into electrical energy. Researchers estimate the high-altitude winds can provide 100 times more energy than currently needed to power the entire planet. At higher altitudes, the wind has more power and velocity, and it is more consistently predictable. That works out to be some 8 to 27 times the power produced at ground level. Right now, almost all wind projects are onshore, and the true energy bounty lives offshore, where winds are stronger and there are fewer restrictions on development. Wind turbines will increasingly move offshore in near future. Our countries like Denmark are already showing the rest of the world just how effective offshore wind energy can be. Nuclear fusion. If there's a holy grail of clean energy generation, it's nuclear fusion, which promises limitless carbon-free power, without producing dangerous nuclear waste. Nuclear energy is gaining increasing importance as a clean source of power, meeting 13 to 14% of the planet's power needs. Fusion is the process that drives our sun. Natural solar fusion generates enormous quantities of heat and light. For decades, researchers have been trying to replicate this process on Earth, or build the sun in a box, as one physicist dubbed it. The basic idea is to take a type of hydrogen gas, heat it to more than 100 million degrees until it forms a thin, fragile cloud called plasma, and then control it with powerful magnets until the atoms fuse and release energy. In simple words, a man-built sun. Fusion has the potential to be a high-efficiency resource that is also extremely clean. Expect more nuclear power plants going forward, but not many. If the technology develops to dependable level, it could well be the new king of the energy world, and could potentially be implemented anywhere. Smart flower solar. Manufacturers of solar systems generating electric power state that the minimum area to supply electricity for the needs of one household should be at least 22 square yards. This is a significant fact to consider. Using the system, Smart Flower Solar, we can forget about the total area of power generating surface. Here are the major reasons for that. First, the system tracks the sun's position. Second, it employs unique panels. These factors make Smart Flower Solar 40% more efficient than its competitors. 12 petals follow the sun from the early morning till twilight, and clean off the dust on their own at the end of the day. On top of that, the system supports optimum temperature not exceeding 7.8 degrees. This technology will definitely become very popular in future. Thank you so much for watching the video. If you like this video, hit the like button, also subscribe to our channel and press the bell icon so you never miss an update.